Hi, I'm Valentin. I'm engineer in the container engines team at Red Hat. And my talk, so when proposing the talk, I thought that the community already knows Podman. At least we're blogging a lot about it. It's also now in RHEL officially for some time. So I wanted to dedicate this talk and talk a little bit about the things that we usually don't present in the talks, because we introduce the tool or the tools. We talk about how new users can approach it, or users coming from Docker or other container tools can migrate to it. So the scheduling of the talks is not ideal in the sense that the follow-up talk will be how to replace Podman with Docker, or Docker with Podman. I'm going to give the next two talks as well, because unfortunately Dan Walsh didn't make it. He had some problems. He wanted to come or to fly via India, but for one reason or another, his visa didn't work. So all the follow-up flights didn't work. So I'm replacing him. I hope this doesn't scare you off. I'm not as entertaining as Dan, but I'm a little bit taller with more hair, so I'm not sure if that if that counts for something. So I briefly mentioned that already. At Red Hat or Fedora, as much as everywhere else, containerization started with Docker. And this is really a great contribution. And they've done an awesome job at making it approachable and usable by others. And over time, the requirements grew. More use cases wanted to be met by customers and also the community. So I compared a little bit to a Swiss Army knife. And the one displayed here actually exists. I think it costs over €1,000 and is 1.1 or 2 kilograms. So where I'm pointing at is the more features you support with one tool means the bigger it gets. So supporting everything comes at a cost. And at Red Hat, or the team, especially Dan, reflected a lot about it. So when you look at Docker, now the situation improved a little bit, but it's being used everywhere for all use cases, on the desktop, on the server, in Kubernetes, which is not true necessarily for all deployments anymore, because there's Containerd, which is more targeted. So this argument may not count anymore. But it's basically meant to support everything. And especially Dan sat down and assembled a team to work a little bit and reflect on how can the future look like, what can we need. And basically the philosophy of Red Hat is to have no one-size-fits-all solution, but to have a set of dedicated and specialized tools which are based on open standards, namely the Open Container Initiative, still being backwards compatible to what has been existing or predates the OCI, meaning Docker, for instance, the different formats, Docker schema 2, the image format, for instance. Everything should be developed in the open, right? Red Hat is an open source company, and all these projects are really open for contributions from outside. This is actually how I joined the team. I came from another company, and I liked the team so much that I said, this is where I want to work. And also to have a certain degree of interoperability among these tools. So if we really want to have something like this, but with a smaller set of tools, they need to be able, or users and we need to be able to compose them in a way to really fit all the needs. So CRI-O, in this case, I'm not going to talk much about CRI-O today, because it's intentionally something boring. Why it's something boring? Because the only use case is Kubernetes. Nothing more, nothing less. So this is a really good example of having a specialized and use case dedicated tool. So what it is, it's basically a container runtime for Kubernetes. So if you're a Kubernetes user, you don't have to worry about this. You actually shouldn't care. This is why we intentionally advertise it as being something really boring. This year in April, it joined the CNCF, which was a really, really good thing for the project because it gains a lot of visibility. The CNCF is a great platform that also supports the growth of the tools. And it's also a certain complement because it shows a certain maturity of the project and also the commitment of the core maintainers to the overall community. It supports all OCI-compatible container images, also including the older Docker formats that I was mentioning before. It can talk to basically any container registry that is out there. There's also different container runtimes, and here you see a certain redundancy in the term runtime because CRI-O is already a runtime, so what is a container runtime when it's already a runtime? This is why especially Dan advertises the terminology of a container engine, which CRI-O, Podman, Docker actually are. So they basically take care of the images and they instruct other tools to actually do all the heavy lifting. So their container runtime is something like runc, crun, then I think from Google there's runsc also, a bunch of container runtimes which actually take a bundle and execute the real container. So this tool actually executes the processes that we see on the host. There's over 100 contributors, more than 90 releases. I guess now we're over 110 releases actually, and we have, actually there's something missing. So on the 150 or 15K per PR means tests. So we run a lot of tests. There's a huge amount of unit tests, of mocking tests, and we actually run the end-to-end test of Kubernetes upstream to make sure we're not regressing on something. In fact, this week, we actually found a regression in the Kubernetes upstream tests. So this is really cool. This is also contributing something back to what we consume. So there's a really good thing going on there. And although sometimes on Twitter it's advertised as only being a Red Hat thing, not necessarily from Red Hat, but competitors, actually there's really a collaboration across the industry. So SUSE is working, actually a core maintainer, Intel, IBM, Lyft, and nowadays also since IBM acquired Red Hat, there's a lot of good things and collaboration going on. I guess I need to hurry a little bit more, right? I like talking about these tools. But there's more tools because there's way more use cases, and those are the tools that I'm going to present today. There's Scopio, which is responsible or meant for distributing images and managing them. It allows for converting them between different formats. I'm going to talk about Scopio at the end of the talk. Then there's Podman, which is, yes, that's really a container engine. And it's responsible for the container, for containers and pods. So pods comes from Kubernetes, which is more or less a glorified group of containers sharing certain resources, namespaces, maybe the PID or network namespace. And then we have Builder, which is responsible for building container images. So all share the same libraries and are developed upstream at the github.com containers project. By sharing all the libraries, we achieve especially the interoperability part that I was referring to before. And also here, it's a collaboration across the industry. Most maintainers are Red Hat, but there are highly non-trivial contributions from outside, and more show interest into helping maintaining the tools. And also across Linux distributions. So I guess the hardest thing is getting a package into Debian, because the packaging Go tools there is inherently different to what Fedora or OpenSUSE are doing. So when you know, are you familiar with Go? Who's familiar with Go, or who is not familiar with Go? Okay, that's good. Only few don't know this pain. So in Go, all dependencies, or there's different ways to compile a Go program, but conventionally all dependencies are put into a folder in the root of the project, which is called vendor, and this means that there's a lot of redundancy. which makes sense, right? So Podman, vendors, containers image, the image library, the storage library, builder, vendors the same, and all of the code is statically compiled. So from a traditional point of view, from a Linux distribution's point of view, this is a little bit terrifying because, right, ideally we have dynamically linked binaries. We just update the binary, the library that might have a vulnerability or a bug. So this makes upgrades from the distribution perspective very easy. And it's something worth doing. In Go, the ecosystem ignores this mostly because of just how Go works. Go comes from Google, and they just deploy everything at once. So it's inherently different to what we are doing. So Podman. I was talking a little bit about it already. So it's a container engine for managing containers and pods. The CLI, so the command line interface, is identical, almost identical to the one of Docker. Why? Because it's a de facto standard for managing containers. Most of the people who are working with containers already know it, so there was no need to introduce yet another thing, which makes migrations way more complex. So adhering to the CLI of Docker makes the transition of users and also scripts much easier. And it's developed at the Containers Libhop project and uses the image library for the image management, the storage library for local storage. It's basically when you explode the container image on your hard drive, it's most likely being stored there. And it supports different kinds of drivers for overlay, Btrfs, VFS, and so on, also S-tree. And Builder for building images. But I've been talking enough, and in the talk after, I'm going to get into the more basic tasks, but now I really want to show you some of the features that I love, but we usually don't talk about much. I want to start with the Podman mount and unmount feature. So what it does, it mounts the rootfs on a container on the host. So what you can do is you do a Podman mount, then it spits out a path on your host, and this is a mount point where you can access the entire rootfs of the container. So some folks are asking, why not just use a volume, right? Volume, there you can mount, or basically a volume allows for sharing files, directories, entire paths among containers and also the host. Because in my opinion, volumes are annoying to use when you want to have a lot of sharing, right? Just sharing root usually doesn't work because then you cannot mount anymore. It's not really useful to operate on the rootfs of the container because it's usually meant the other way around, that you're mounting something into the container. So we come from a different perspective, a different angle here. And it's generally useful for sharing data, but not for altering data in a generic way. So why not just use copy in this case? Because copy would just be a workaround if we add it, because we first have to copy data from the container to the host, then edit the data, and then copy it back. With Podman mount, it can be as easy as displayed here, right? We run an exemplary container, Fedora 30, then we unshare. Why do we need to unshare? Because we're running rootless, and we, by default overlay, we don't have enough rights to mount. By unsharing, we create a new user namespace where we then have the rights to do it. And yeah, then we do a Podman mount. We get back the path, which is then in the mat variable. And if I grab for S release, you can see that, well, it's a Fedora container image. And this is really cool for specific use cases. For instance, if you have certain scripts or that you don't want to adjust to the specific container images that you're running, if you want to have something generic and not specialized in a sense, because you might want to run Fedora container, a Debian container, an Ubuntu container, Arch container, and you don't want to find out about all the specifics, but you know exactly the host system that it's running on. This is something really nice.
So here we are just mounting the etc because you are just wrapping the name from the obselete. It means it's supposed to be non-mount modifier.
I forgot etc there in the path. That's right. So I adjusted the code. Yeah. So there is the etc missing. So we really mount the entire rootfs there. Here in this example, I just screwed it while copying into the program, which is generating these nice images here. But thanks for noticing it. I will update it. Then next topic is managing container images. So here, once on my local system, I had really a lot of things going on. Because I use it for development, I use it for running specific tools, right? Things can get messy. And oftentimes I want to clean up, but I don't want to remove everything. But I want to find out, okay, how did I come to this? And there's a pretty cool feature which has been contributed by NTP, which is a company in Japan, which has a very, very good team, which is contributing a lot in the containers ecosystem. So, and this is called Podman image tree. Podman image tree lists, or basically checks the image, analyzes the layers, and spits them out in a tree format. So if we look here, we first download WordPress, then PHP 7.2 Apache, and if we then run Podman image tree on the WordPress image, it spits out a few things. I'm trying to use this. I'm really bad with. Okay, I don't know how to use the laser pointer apparently. Well, what you can see is the image ID tags, so all tags that are associated to the top layer of this image, right? One image can have multiple tags. Those would be displayed here in a list. It spits out the size, so you know how big or how much disk size it consumes. And then it lists the layers below, and there we can see that the WordPress binary, the WordPress image is based on the PHP Apache one. So this is really useful to figure out which layers does my image actually use, because quite often if you download something from the web, the dependencies and where it comes from is not very trivial to find out. But it can also go the other way around. If we want to figure out which layers require my image, then we can pass the what requires option, and then it goes in the other direction. And this is actually really, really helpful, or at least for me. I'm not sure if you suffer the same use cases. I think I was implementing or working on a feature for the containers image library, and some tests were not passing anymore. And I knew there was something wrong with the layers. And with Podman image tree, I really understood what was wrong. So also during development, it can be really, really helpful. So in a nutshell, Podman image tree prints the layer hierarchy of an image in a tree format. It can show you which layers does my image consist of. So basically explode everything there. We could find out that WordPress is using the PHP Apache one. And also to figure out which layers actually use me, or the image I'm currently looking at. It also matches layers to tags. So when you look here, you see the top layer of line at the end, but this only works when the image is pulled. So if we don't know the tag, we may download the image from the registry, or sorry, the layer from the registry. But to know the top layer, we also need to download the image. Only then we have the knowledge in case you want to use it and ask, okay, I downloaded it. Valentin said this is going to be there, but you need really both images. This is why we pull both here too. And it can help in understanding the dependencies among the images, and it can also really help in image builds. So I'm building something, let's assume we have a complex Docker file and want to see really what the image is made of, or how the layer hierarchy looks like, without inspecting the image and then trying to extract it from there. And as I've mentioned before, it already helped me really debug during development. The next feature here is one of my favorites. If I love all of them, but if I would choose, I may love this a little bit more. Some people think I'm insane because of it, but I really see a beauty in it. So let's get straight to it. First, we see the Docker file, right? We have from Fedora, so we base our image on the Fedora 30, 31, and then I'm adding a label here. So we say label, echo label, so this is basically the key. Everything that follows is the value of the label, Podman run image echo hello flock. Then we build it with Podman build. And when I execute Podman container run label and specify a label, like a key to look for, and an image, Podman will parse the config of the image, look for the labels, try and looks up the label that we specified, and then execute the value of the label on the host. So as we can see here, it's in this case running the image and runs echo hello flock there. The problem is run label can execute any command on the host. And as you may think, this is not necessarily a good thing to do. But I don't suggest to abandon common sense. In any case, we shouldn't download or pull random images from the web or from some registry and just blindly trust it. And this is especially true for the run label. There, we really need to trust the image, and we really need to know what is going to happen. Why do I like it so much? Because it somehow lifts what an image can do. Usually the image specification of the Docker format, or also the open OCI format, is a little bit limited. And this is intentional, because the standard, or the OCI, is meant to be the, sorry I'm not native, the smallest common denominator, right? It should be something that everybody can use and is as less specialized as possible, to not close doors at the beginning. So what the image, when we create an image, we can specify the commands inside, we can specify the environment variables, we can add a lot of metadata, as we do, for instance, with the labels, and a bunch of security switches, for instance, running it privileged. I'm not actually sure the AppArmor profile, but it's very limited in a sense. With using run label, we can add a lot more information to the image. So if we know that a certain image must be executed by the container engine in a specific way. So the container engine, Podman or Docker, they have a lot of switches, basically, that we need to specify things. May it be mount points, may it be an AppArmor profile, an SE Linux label, SecComp profiles, things like that. Or if the image has certain requirements on the host where it's being executed, maybe we need to install a certain package on the host for whatever reason. Then run label is a really, really great way of doing it, because especially in automation, because if you know or if you have a convention for using a specific label, the developers or the creators of the image know how the new version must be executed. They just update the run label, and basically your servers just need to execute the run label and everything will work. But again, this is something that should be used with care. Yeah?
Is there a way to know what kind of run label it points to without actually running the label?
Yeah. So you can inspect the image. So you could, if you want to have a look at it before, you can do a Podman inspect and then use the format filter, or just look at the entire JSON output, and then you can expect it. So it's really, it's something transparent. Nothing is hidden. The metadata is obvious at that point.
That's probably a better way of trying to Have you looked at the label you
Yeah, definitely, definitely. So in the end, there's no magic behind it. In theory, you can come up with a convention and use it with other container engines than Podman, for instance. But this is just a way to automate it, right? And to have semi-standard, at least for Podman. All right. Any more questions on run label? I'm happy that there was a question because I like it so much. Yeah.
Should the last line on that slide be hello belt, not hello flock?
Yeah, that's again a copy, a copy thing. I copied it from a blog post I wrote for a German news or IT news website, and I wanted it to relabel it to flock to make it a little bit more appealing. But yeah, in this case, it should have thrown an error. Yeah. All right. So I saw a few people running around with "Everybody Loves Systemd" t-shirts, and well, this is something maybe not everybody does, but we all have to live with it, and we cannot hide from it. And one big problem in the containers ecosystem for a long while was the Systemd support, right? So running, and we need to see it from various angles. We can use Systemd on the host and use, for instance, a unit file as displayed below to execute a container. With Podman, this works really well because the way Podman executes or runs a container is inherently different to Docker. Podman follows the fork exec model. So all containers are really children of the Podman process, which makes things quite more appealing. It's easier for service management, as we can see here, because then really Systemd has full control over it. For instance, C groups. So if we specify certain limits, those limits will be applied to the container. If we do it with Docker, the limits will only be applied to the Docker client, and the Docker client will send a remote procedure call to the Docker daemon. And in this case, it won't work. Also, it can send SD notify messages. So if another unit file depends on the successful execution or start of the container, this works as well. Whereas for the Docker client, we're not sure if the service is actually running at the point the client terminates or exits. So if, for instance, here's an exemplary Systemd unit file for a Redis container, it's pretty straightforward. We can implement a restart always one. So when you look at Docker, for instance, Docker does all these things in the daemon, or has to do all these things in the daemon. That's just because, or a consequence of the architectural choices the developers had, which is perfectly fine, but it has certain limitations when we want to use it in a Systemd unit file. To make things a little bit more easy, Podman allows for generating those Systemd unit files. So here we call a Podman generate Systemd flock. So flock is a container I've been starting before, and it spits out a Systemd unit file that we can use directly or use as a template for further extension. So if you look at the third last line, there is first, what we see is it's a rootless container because the container storage is in my home directory. And then there is a .pid file. One thing I missed by trimming the line is that there is a conmon.pid file. So in case you ask what this is, the conmon stands for container monitor. And it's a process sitting between Podman and the runtime. So Podman is not directly calling runc, but it's instructing conmon to run runc. Then it double forks for the reasons of being able to run in the background and not having problems if Podman exits or is being killed. And it provides a socket that we can use for attaching. So if you do a Podman exec, Podman will actually attach to the socket of conmon, and conmon will stream everything out. Conmon is also used to log, for logging. So there's 2 drivers supported at the moment. You can either log to a file on disk, or use directly the systemd journal. So then you can do your journal CTL, yada yada, and look up what's going on. It also keeps a bunch of file descriptors and ports open. Basically, we have to do this, if not the container cannot access the ports, for instance. And it also records the container's exit time and code. So Conmon, so when saying Podman is no daemon, it's factually true, but only because there is Conmon. Because some process needs to watch the containers, right? What's happening, to record the exit code, keep the sockets open, and all these things. And Conmon is basically used to prevent Podman from being a daemon. But to be fair, at least we believe it's the smallest possible daemon. It's 76K in now the 1.0.0 release, and yeah, it's pretty small. It's also written in C, not in Go. So the next use case for systemd is to have it in containers, right? If we have a Docker file, yum install httpd, this requires systemd because it's being started by systemd unit files. If we don't have systemd in a container because the container engine doesn't support it, because systemd is a little bit special in the requirements it has for the mount points. For instance, it wants run lock, a temp, and varlog journal as a tempfs, and it wants to bind mount or needs to bind mount sysfs cgroup of systemd so that systemd can actually talk. Then we have a problem. And this problem existed for a long while. So what we had to do, or what basically everybody was left alone with the task of writing init scripts. So everybody had to write some bash scripts to start the services instead of just doing systemctl enable, maybe even in the build of the container. So whenever you execute the container, the service starts automatically. For Docker, the team wrote a few years ago the systemd OCI hook, which, so an OCI hook is a standardized way of telling OCI-compatible runtimes to execute certain binaries at a specific point of execution. You can compare it like certain steps in a compiler, certain paths in a compiler. And this is happening here as well. So at start and at stop, the systemd OCI hook was being executed. It was setting up the mount points that Podman now does implicitly, and then did some cleanups as well. So with Podman, as I was already saying now, is that it has built-in support for it, because this is something we need. We don't want people to manually write init scripts, because this is a problem that has been solved already and threw us back by a decade or so. And we want a container not to be something special that people need to treat or what people need to create or think differently. It's really just a glorified process on the host. This is why I already see the cool T-shirt in the back. Containers are Linux, and this pretty much nails it. So there's no workarounds needed anymore. We can just install the packages, and this is something I really find nice. It's not something amazing in the sense that it's innovative. It's just something normal, and this is the nice point of it. One of a common feature that is being demanded or asked for by the community, especially by folks migrating from Docker, is if Podman supports Docker Compose, right? Docker Compose is a declarative way to start a set of containers and that basically compose a bigger service, right? You may want to start your web server independently from your database because it makes sense from the microservice point of view. And this is a nice way to do it. But we don't. Why? Because the Red Hat and the core team really believes that Kubernetes is the now de facto standard way to do such things. And Podman Compose does a great job, but we don't want to invest resources into supporting it. We're not closing doors, so if people want to contribute upstream, they're more than welcome to do it, but so far the need hasn't been apparently big enough to invest resources into putting it or supporting it officially in Podman. However, there's a Python wrapper by Muyad Al-Sadi, who is very active in the Fedora community as well. And apparently this works well. It has been received super positively by the community. Alternatively, we want people, or the alternative that basically Podman offers is it supports a Kubernetes YAML file. So usually what you throw at kubectl, you can now throw at Podman, but you don't need a Kubernetes cluster to run it. You can really use it locally. And this is, I find, amazing, because sometimes we have to debug things, or if I want to run a certain Kubernetes YAML file, but I don't want to spin up a big cluster, or maybe if I don't have access to it, then I can just use it. So it's a bridge between local development and the cloud native world. And I find this really nice. So if people have existing deployments that are based on Podman Compose, there is another way to migrate to Kubernetes YAML, which is using Compose, which is a tool under the official Kubernetes umbrella, which converts Docker Compose files into Kubernetes YAML file. So there is a migration path between the two worlds. And so here we somehow thought, if we can already read the file, why not generate the file based on an existing container? So you may wanna, or you may already have some containers running locally. Then you say, okay, I want to push this thing now into Kubernetes. You can do a Podman generate kube on the container or on the pod, depending on what you're having. And then Podman will spit out a Kubernetes YAML file that you can use. So here I had to trim it a little bit. It's really just a standard Kubernetes YAML. We have a pod, certain metadata, then the spec of it. We can see that the command is sleep with an infinity argument. We have the environment list. The image is the Fedora 31. We have a name, and it's an unprivileged container. I was hiding a lot of information that was not necessarily important for what I'm trying to say here, but this is really an easy way. As the first line says, it's still under development. This is not an easy thing to do, but we plan to basically make this a really stable thing. At the moment, it will work for most things. Please don't nail me to it. Yeah, famous last words. But this is how the team and the maintainers envision the future and where they want to support different kinds of needs. It's also, so the cool thing about Kubernetes YAML is also a nice way to declare what you're trying to execute, so you don't need to have a shell script anymore where you want to do it, or maybe even run container run label because everything is specified here. You can also just put everything into a Kubernetes YAML file and do the same thing. Podman checkpoint and restore. This is a feature that is supported since Podman, since the 1.0 release. So what you can do is you have a container, you checkpoint it, and you restore it on another machine. So it allows for migrating containers among machines. Personally, I cannot go into all the technical details because I didn't implement it at all. It's a very, very complex thing, and Adrian Reber did this. We're using Cryo, which allows for migrating processes. A lot of things happen there in user space. But what we can do here is, as shown in the example, we run a container, we checkpoint the container, we export it into a tar archive, we copy it to another machine. In this case, it was just a virtual machine that was running on my notebook here. Then we restore it by importing the tar archive, and then we can start it, and it will just start. Yes?
So what would be the use case for this, something like export or import?
The use case? You mean a container export and import? All right, here everything is frozen, so the container, the processes execute where they were frozen before. So yes, you can do you can export a running container also in a tar archive, but what is happening there? It's a very good question. I will remember it. What usually happens when you do an export, like a Docker export or Podman export, what it does is it looks at the current rootfs, it commits it to a layer and makes an image out of it. So when you start the image, it will create a new process. So it will execute the entry point and then the command. With checkpoint and restore, it really freezes the process and starts executing at the point of the restore, or where it has been frozen before. Does this answer your question? Okay, so perfect, thanks. So much to Podman. There's still a few other tools, and I seem to talk very slow. Some resources, if you're interested. Upstream development and the community is on github.com, containers libpod. There is a channel on Freenode, Podman. There's also a mailing list, which has been introduced, I guess, a month ago or so, Podman at lists.podman.io, and also the website podman.io. We try to blog there regularly and share resources from other pages as well. And it's available on most Linux distributions. I cannot say all because I don't know all distributions, but I think you will see some major ones here. For sure, there's Red Hat Enterprise Linux and Fedora. There's also OpenSUSE. I think our friends at SUSE are also planning to support it in SUSE Linux Enterprise, which is a really cool thing. On Manjaro, Gentoo, Arch Linux, Ubuntu, and on Debian. But as I've said before, Debian is a really Herculean task because all the dependencies that others have in the vendor folder have to be put into separate, dedicated dep source packages. This is really hard because not many tools share the dependencies, so Docker, Podman, Scopio, Builder, and whoever, and they will certainly have different versions. So you have to package different versions, and this is really, really a tough problem. Now let's come to Builder, or how Dan would say Builder, but I can't imitate his Boston accent so well. So Builder is dedicated for building container images. Parts of the source code are actually used in Podman build. So now I'm trying to tell you why and when you should use Builder instead of Podman. Because it goes beyond the functionality that a Docker or Podman build have, which solely works with a Docker file. And it's meant to be used as a low-level core utils-like tool for building container images. It's also built upstream on the GitHub Containers project and shares the image in the storage library with the other tools as well. Builder supports using Docker files, with Builder build using Dockerfile, or just for the lazy ones, Builder bud. Like Podman, it can run rootless, same architecture than Podman, no daemon, besides Conmon. It focuses on OCI standards and on open development as much as the other tools. And it's also targeted towards Kubernetes, or the build pipeline specifically. So Builder is offered on Quay, or you can download a Builder image. And in a later talk today, I will present how we can use it, or basically how also Red Hat is using it internally for build pipelines. There's a lot of cool things we can do with it to speed up builds and secure them. So a common question is, does Builder have a scripting language? Perhaps Builder file. And here I'm shamelessly copying Dan's joke. Yes, there is Bash, and this is Builder's ultimate scripting language. What I mean by it, what we can do is we do a Builder from, it could be any image. Here we build a new one from scratch. Then we mount the container, which is the same thing as we've done previously for Podman. It's the same concept. We get the mount point of the working container that we use to create an image. And then we can do whatever we want on it. We can do a DNF and install root on this mount point and use the host's DNF and all the repositories on the host and install stuff there. So in theory, you can create images without RPM, without YUM, without DNF, very minimal footprint, or whatever you want to do on the container. Then we can unmount it, and then Builder commit creates a new image based on the current state of this container. So this is really envisioned as a way to create tools that are more complex, that have specific needs, and use Builder as at the very low or maybe lowest possible level and build more complex things around it. Another cool feature that I like a lot and that we constantly fail to advertise is that Builder supports including other Docker files. This is a feature that has been asked for, I guess, since 2013 or 14 upstream at Docker. But the maintainers are very reluctant, which I understand because the Docker file syntax doesn't support include. And if they introduce it now, older versions of Docker will break, and this is something really hard. Dealing with backwards and forward compatibility is a very tough thing to do. So we were thinking about what we can do. People still want to use Docker files, and we still want to use Docker files. But we also want to be able to include another Docker file. Why? Because we have a lot of boilerplate code, a lot of Docker files. If you work with them, you might know it. There's a lot of DNF update, DNF install, then cleaning the cache, and most of them use or install common packages. You might not want to rebase them on one another, but because maybe you wanna make one layer out of them instead of squash all the layers, for instance. So what we are doing here is we use the C preprocessor. So this way we can include another file. We can include any file, because in line 3 you see the include directive, which is basically exactly what we want to do. The C preprocessor, among many other nasty things, it does textual replacement. It takes the contents of the one file that we're including and copies it at the point there. Yes?
Does that mean I also can use C macros in all of the preprocessor magic?
Yes, you can. This is why some people say we shouldn't do it, but it's really up to the user. So if you like CPP macros, you're free to do it. So we're doing it. So this is something that anybody can do. You can run the C preprocessor on your system and basically use this and throw it at Docker as well. What Builder is doing, or also Podman in this case, is whenever a file has the .in suffix, then we pre-process it before. And this is a way to achieve it. Again, it's somehow the same philosophy behind. We don't want to reinvent something. We use something that's already there. And the C preprocessor is as old as Unix, basically. So this is something that you can even install on Windows. So this is something really nice, and I like it because it's a very approachable way of achieving the task. For Builder, same as for Podman, upstream on GitHub containers, we're on Freenode. It has its own website and also a list feel free and invited to join, and it's available on the same Linux distros as Podman. Last but not least, Scopio. So Scopio is a tool for managing and distributing container images. It's basically the first tool of the github.com containers family, and I think it's the most widely used tool, not only due to its age, because it's older than all our other tools, but it seems to be a really serious problem. So it's used in many non-Docker pipelines to push images, for instance, in the open build service of SUSE and OpenSUSE. They use Umoji for building container images, but then they also need to push them to a registry, right? We need to make them available, and Scopio does a very, very good job at that. And originally, Scopio was born by the desire to inspect remote images. I guess it was in 2014 or so. Antonio Mordaca, a colleague from Red Hat, opened a pull request at Docker, adding the Docker inspect command. What it wanted to do is to contact the registry, download the config and metadata, and display it. And the maintainers liked the idea, but still rejected the pull request because they said, well, sorry, the command line is getting more and more complex, and we understand this. But they said, well, a container registry is nothing but a web server. So in theory, you can curl everything. And then Antonio sat down and said, okay, cool, I'm going to do it. And this is how Scopio was born. So here's an example. We do a Scopio inspect. Docker, the Docker prefix means we're talking to a Docker registry. There's different transports that I'm going to present in the next slide. On the Fedora latest one, and then it spits out a bunch of information that we can use for post-processing or just exploring what's going on. How does the image look like? We also see the layers. So in theory, you can write a bash script which also does something like Podman image tree around Scopio inspect. So here you see the degree of interoperability I was also referring to before, because all share the same libraries. So Scopio supports multiple so-called transports. So when you do a Podman pull, it uses the Docker transport for pulling the image into the container storage one. So container storage is the local container storage. We support different drivers, overlay, or Btrfs. In fact, back then it has been a fork of Docker, the Docker code. We can't use the storage library of Docker or Containerd directly because because they're not a daemon. The tools are daemonless, besides Cryo, but all the tools are daemonless. So when we have to sync, we cannot use memory mechanisms like semaphore or a mutex. We really have to go down to the file system, use file logs for it. So there was a lot of refactoring going on and supporting use cases where the tools run in parallel. So this is the price you have to pay when you're not a daemon. It also supports a directory transport, which is a non-standardized way to explode an image to a specific directory. So there you can explore it, you can check out the manifest of the images and things like this. Besides Docker, we also support OCI. So this is basically an implementation of the OCI image specification. And it can also be compressed like Docker Save or Podman Save as a tar archive. And last but not least, there's also support for OS3. So the different transports give a lot of flexibility. It works rootless where possible, so you don't need to root for Scopio. Certainly there are limitations. So if you want to talk to the Docker daemon and copy an image from there, you need root because the Docker daemon in this case requires root. And it's a non-opinionated way of managing images. So there's copy, inspect, and delete, and very limited functionality, so users can build something more complex around it. And as I'm repeating myself quite a lot with it, but they all share the same library. So if you do a Podman pull, it's basically the same as a Scopio copy. Docker, yada yada, container storage, yada yada. And it's easy to integrate into the tool chains. So here you can inspect, for instance, the Fedora rawhide image and just use JQ to inspect the fields of the JSON. Same as here, but Scopio does not have a dedicated website. Everything is upstream on GitHub. If you want to reach out to the developers, you can use the containers channel on Freenode, and it's available on basically the same Linux distributions. But Debian already has it in the main repositories. So I started the talk with the big, huge Swiss Army knife, which does things well, but it has some side effects or some consequences. May it be security, may it be you just don't have root on your system. So the philosophy of Red Hat there is to have smaller, more specialized tools. So you can really choose based on your use case. And that's pretty much it. Do you have questions? Yes?
Just on like the container storage end, I was just wondering if there's anything that thought about like adding support for other kind of file systems or other drivers on the container storage level. Is that like something that would be like flexible for someone else to like add in third-party support for another file system, like CDMS is one that I was thinking of?
Yeah. Yeah, that's pretty straightforward. So the interfaces, all of the different drivers use the same interfaces, and it's no rocket science. There's a few things when it comes to layers. You have to store it, you have to compute a diff between two layers, you have to apply a diff, you have to extract it. Sometimes, depending on what you want to do, you may want to compress it or decompress it. But extending it for new drivers is something I can only encourage. If you have the use case, we would be happy to know it. The same applies to different transports also in containers image, for instance. It's a fairly stable interface we have there. Sometimes we need to change it, but if it's upstream, we commit to maintaining it. So basically it's the same thing as with the Linux kernel. As soon as you get it upstream, the maintainers will take care. Any more questions? All right, so I guess we're going to hang out for the next hour as well, because unfortunately Dan Walsh is not here. So after that, if you see him, please remind him he owes me 1 or 2 beers. So now, we still have a few minutes. If you want to use the restrooms or refresh yourself or get some drinks, I'm going to wait for you. All right, I think the talk is supposed to start 3 minutes ago. So, as you see, I'm a taller, younger version of Dan Walsh with a little bit more hair. Unfortunately, he didn't make it. He had some problems traveling because he wanted to travel to DEF CONF in India, and something went wrong with a visa, and now he's stuck in Boston. But I'm Valentin. I'm working in Dan's team on Podman, Builder, Cryo, basically a little bit on all the things there, more kind of a generalist. So I hope to replace Dan. If you see him, remind him he owes me a beer. He will know why. So.
I flew all the way to India just to see his presentation and he didn't show up. So I came here and he's still not.
Oh, I'm going to throw that at his head. I will have a lot of fun. So in the talk before, I was talking about somehow the untold features of Podman, which are mostly things that Docker doesn't support. So Podman and Docker, they share a lot of features on the CLI. So when Dan's team came up with the idea of creating a daemonless container engine, the decision was clear to also basically imitate Docker on the CLI. Why? Because we're all used to it. They did a great job. Everybody knows it. Scripts already shell out to it. So just sticking to it makes sense. It's a de facto standard CLI. So in this talk, Dan wants to show how Podman works, how you can migrate from Docker to Podman, explaining a few of the technical details that Podman has, explaining the architecture, how Podman uses user namespaces to also implement rootless containers. So if you don't like the talk, you also have to complain to Dan. So let's get the demo started. Let's first execute everything as root as we're used to. Here we see the version. We have a remote API version. We see the Go version, which is basically also used a little bit for debugging, and the OS and architecture that's being used by the Go compiler. The remote API is implemented in varlink, and we're really committed to make this a stable thing for Podman. The cockpit, which is also used in Fedora, is basically using the varlink API to do it. So this one, excuse me, I have to make it a little bit shorter. So now, yeah, there we can do it. So if we do a Podman info, it's similar to Docker info, where it displays basically most things that Podman uses for execution, and also most things we need to understand in bug reports. So what we can see here is Conmon. Those who have attended the talk before know Conmon already. So Conmon stands for Container Monitor, and it's a small binary sitting between Podman and the container runtime, for instance, runc. And what it does is it keeps a socket open that Podman can attach to. For instance, when we do a Podman exec, it uses this socket. It also keeps a bunch of file descriptors open, for instance, to keep ports open. It records the exit code, puts it into a file, so Podman actually knows what the exit code of the container was, which in case of Docker, for instance, does containerd and then reports it back to Docker. It also does logging. So Conmon is, so when saying Podman is rootless, it's factually true, but a little lie. Just a very little one, because from a technical point of view, we need some process to monitor the containers. And this is what Conmon is, only this. However, we believe Conmon is the smallest daemon possible for this task. It has 76K, it's 76K big. So there's not much. A lot of other things. We have the OCI runtime, the path to it, also the version and the commit. Unfortunately, there's still no stable or no 1.0 release of runc because things are popping up all the time and are blocking the release. So Docker is using a different version of runc than Podman, and maybe Cryo is using another one because things are changing rather quickly, and when you have when something is changing quickly, you maybe need to pin to a specific commit where you know this is just working. Containerd does the same. So this is why we display this information as well. And a lot of other things. The uptime. Yesterday it looked nicer. I had around 10 days, but I rebooted this morning. It shows also a bunch of registries and search registries. So search registries is something I like and hate at the same time. I like it because it's nice for users, and I hate it because it's really painful to develop and maintain the code in the background. So when you do a Docker pull Alpine, Docker is doing a lot of things for you because it's resolving the name into docker.io/library/alpine:\latest. And we wanted to have the same thing also for other registries. So when you do Podman pull yada yada, and we don't find yada yada on docker.io, Podman will go through the list, or basically the container's image library, will iterate over all items in the list you see here in the search list, and contact the registries one after another. So then it will ask registry fedora.org, do you have yada yada, and then iterate over it. So it's something you can configure. So it's something really nice to use, but it adds a lot of complexity in the code, because there's a lot of special casing, and Docker I/O is always something special and will always be something special. Then we have a bunch of config switches and option for the container storage. So there's a container storage conf that can be configured for all the tools that are based on the container storage library. There you can alter, for instance, the paths where images are being stored, where containers are being stored. You can control which backend driver the tool should use, or the storage backend should be using. Maybe Btrfs if you're running on OpenSUSE, maybe overlay if you're on XFS or X4, and you can also point it to the mount program that is being used, which is something we need for rootless. I'm gonna talk a little bit more about this later in the next talk, in the following talk after, where we go into the details of Builder. Same for the image store. Well, I guess you get the idea of what you can do and what you can see. So now I'm gonna increase it a little bit. So here we have a Docker file from Alpine. We can set the environment, a label, so add some metadata to it. And the important part is the bud here. Everything before you can more or less ignore for now. This is just to run the demo. But the bud is basically instructs Podman to build the Docker file that we're seeing above. I was talking too long, so I need to re-enter my password. So here we can see we can execute the Docker file, parse it, run everything. We're pulling it at the moment, and voila, we have a new image. So the last digest we're seeing here is the image ID of the container image that we're just building before. Can you still read it? Okay, perfect. Then I might just keep this font size. Next one is images. Like Docker images, we have a Podman images, and have a look at the container images that were here. RMI stands for remove image. And one thing that has been asked for a long time upstream at Docker is, please give us a switch to remove everything, because it's a common feature, because things get messy quickly. But the maintainers didn't want it. Podman supports it. It's trivial. You list the images, you iterate over them, and then you remove them. So it was no rocket science, but something really that improves the usability of the tool. So here we see we had the two images before, localhost my image and the Alpine one. We see that both have been removed. So now Dan wants to do more cleanup. Podman RM does the same, but for the containers. We remove all the containers. So we had one for building, and we executed a few before. So basically, this is the leftovers we're having. Now it's the nice part. Everybody likes Podman because we can execute it as non-root. And actually, lately, we have been approached a lot by the HPC community, high performance computing. So they can't really use Docker because they don't get root. If you have a big HPC environment, you can do nothing. And well, for Docker, at least until now, you needed root for a long while. Now it allows for executing it also per user. Nonetheless, there's a lot of interest in rootless, and it's really cool to see the different use cases they're having. So let's dive a little bit into it. We can do the same. We pull an image. I hope you're not downloading too much here. Okay, I already had it here. So you can see here in the output that the pull or the download has been skipped because it already exists in the source, in the destination transport, which in this case is containers storage. This year, we've been working a lot on improvements for pull. So it's easy to compare performance, especially when you migrate. And let's say internal customers at Red Hat said like, well, it's working, but the pulls are really slow, and that's a bottleneck. So what we were doing before is all layers have been pulled in one after another. Sorry, I'm missing my English at the moment. So the obvious thing was to parallelize everything, but this was a rather non-trivial change because the tools Podman, Builder, Cryo, Scopio all share the containers image library, and well, there was a lot of synchronization going on. But now we're faster than Docker, which is cool. Also considering that it's a daemonless architecture, so the process has to be initialized before, and yeah, that's really nice. So rootless, we can also run a container. We can now show all non-privileged containers. So if you run Podman ps, you can basically list the containers. -a will list all, so also the ones that are not running anymore. You can't see, however, containers from root. So it's different storages. We don't have access there. So this is something that is different. If you pull an image for root and pull the same image for non-root or for a user, you have to pull it twice because it's just different storages. Same goes here, Podman images. Now we do a sudo Podman images and we see, well, they're not having the same containers. Well, okay, they're close to the same because I'm running a lot of root and rootless with the demos here. So now Dan wants to show a little bit behind the curtain. How is Podman using user namespaces? How is this working? So I'm going to read a little bit. The demo will now unshare the user namespace of a rootless container using the builder unshare command. So what builder unshare does, it creates a new user namespace where we have more privileges than in the current one. Podman now supports the same. Actually, Divyansh, you added Podman unshare, right? That's cool. So first, we have a look outside the container and look at the etc sub UID. So what we're seeing here is the UID map that the user, in this case Valentin, which is me, has been assigned to. So the first item in the colons separated list is the UID or the username. The second one is a UID of the range that we can use in user namespaces. So when we create a new user namespace, this is basically the starting ID that we can use. And the last item, the 65K, is the range or the number of UIDs that can be assigned to. So 0 will be 100K, 1 will be 100K, 1, and this goes up to 100, 165K, and so on. So when we do, now we create a new user namespace. We're leaving the one, create a new one, and if we now have a look at the UID map that is assigned to me, so we can see that 0 in the user namespace, so the root in the user namespace, is UID 1000 outside the user namespace, which happens to be me. So what we're basically seeing here is that inside the user namespace, the process is root and has the same rights or has root privileges inside this user namespace, but outside in the parent user namespace, it has ID or user ID 1000. So even if we manage to break out of the user namespace, we can't do many nasty things, or only as much as the user can do in any case. All right, and then we have the UID, or the ID1, which starts exactly the way I described before. So 1 starts at 100K, and then all the following 65Ks. So I think now Dan wants me to exit. We clear. And now we're going to look at the Podman user namespace support. So what we're seeing here is something we can also control on the CLI. So here we have another UID map, a new range starting at 100,000 and with a length or the range of 5,000. We do a sleep and create a new container. And now I may regret it because I should have cleaned up my processes. So I'm not sure if the next call will actually succeed. But what we're doing now, we use the Podman top command on the latest container, so the last created container. And we're going to display the user and the host user, H user, and grab a little bit on it. And oh, nice. Okay. We see that the host user is 100K, which is exactly what we've been specifying in the UID map above, but is root inside. And later I'm going to show a little bit more about Podman top. So Podman top has been extended quite extensively to make it easier to explore what's going on in the container. And if we do the same on the host, we see here that it has actually, basically here we see the process running on the host. This is the ID. Here we have the PID, and this is basically how, or meant to illustrate how a UID map works. We can do the same starting at 200K, same as we've done before, and here we go. Do you have questions? Perfect. All right, let's dive a little bit into Podman fork exec model. So this is basically the biggest differentiator between Docker and Podman. So Docker has a client-server model. So whenever you execute Docker run, you're not talking directly to the Docker binary, or in some sense, yes, but there's another one called the Docker D, the Docker daemon. So what the Docker client does, it sends a remote procedure call to the daemon, and the daemon will do all the heavy lifting for it. This is, in one sense, great because everything is centralized in the daemon. All state is there. It makes development faster and also erases a lot of sources or potential for bugs, mainly because Podman and the others have to synchronize on disk, right? We can't use mutexes, we can't use semaphores, all the cool things that Docker can do, we can't. However, it comes at a price. It makes everything a little bit slower. And it's quite hard, or harder, to integrate into existing Linuxes. So, for instance, when you want to use it in systemd unit files, you cannot really use the cgroup restrictions on it because they will be only applied to the client process, but not to the daemon, and hence not to the container processes. So, this is a little bit hairy. Podman has a fork exec model, which allows for an easier and smoother integration into the system. Same applies to audit, for instance. I guess Dan will show it in a few minutes here in the demo. And so all containers executed by Podman are child processes of Podman itself. And this changes everything. So the login UID will be following. We can see who has been executing what on the system. It's easier to be used in systemd and so forth. So, yeah. Dan will tell it now. So if we look at the log and UID, it has the ID 1000. So the log and UID is something that is set once to a process and can never be changed. So the Linux kernel makes sure. So it's actually in the proc structure of each process. The Linux kernel will make sure it will never be changed again. And this is following me as soon as I log in. So whenever I log into my machine and execute something, this log and UID is attached to all processes. Everything I do is attached there, and this is what I'm going to show now. So if I run Podman, a Fedora container, and execute a log and UID, well, it's the same. If I do the same with Docker, now I should make sure to also start Docker. If I do the same with Docker, like, holy crap, what's that? Well, the parent of the Docker daemon is systemd. And systemd is the init process. So there is no login attached to it. So the value we see here is basically an overflow. This is something that can never happen on the system. And this is what I mean. It comes at a price to have a daemon. So, for instance, in the audit subsystem, let's say we wanna secure or watch etc shadow, right? There's a lot of necessary information that we might want to know what's going on in etc shadow, because if somebody has write access to it, then they can log into the system and do whatever they want. So let's put it under audit control. So the audit subsystem will watch it. And now we're going to create a Fedora container. We're going to volume mount the root on my host into the host or into a path in the container and touch etc shadow. When we're now using a usearch and check what has recently happening on the etc shadow file, well, we see, Valentin has done something there. So it's being logged. The system can assign it or map it to my user, and as an admin, or if I want to see what has happened on my system, I know who did it. So now it's me to blame. If I do the same with Docker and check who has done it, it's unset. Well, this is a problem, and this is actually a blocker of using Docker in certain environments, because certain security certifications actually require that everything is auditable. Yes, now we come to the top features that I was mentioning before. So now let's first start a container, and now we use Podman top to display the PID in the container. And, well, maybe we want to do some debugging or understand what actually is a container. It's really helpful to use Podman top. HPID, we map it to the corresponding PID on the host, which is basically the PID in the parent user and PID namespace. This is pretty nice. We can also list the SE Linux label. We can check if a seccomp filter is enabled for the process, which can be useful to figure out or see if my seccomp profile that I'm writing and attached to the container is actually effective. We can also list the capabilities. So there's a lot of different capabilities that a process can have. One of them, and which is the biggest one, is the caps sysadmin one, which is close to be something like root. And in the next talk, I'm going to talk about how we support overlay for for rootless containers, because if an overlay for mounting requires capsysadmin. All right, this is a demo, so something must have gone wrong. But one thing I want to look at Podman top. Yeah, we still have a lot of time to look a little bit at what Podman top supports. So here it's a little bit funny because Podman top is actually a PS, but Podman PS shows the containers. So yeah, well, it's an inheritance from the Docker CLI, but I wouldn't have known any other way. So in case you wonder why I'm now comparing it to PS1, because that is actually what has been happening before. So Docker top or runc top, they're basically executing PS and do some parsing and try to map the PID in the container to the PID on the host and things like this. And PS is nice, but it's really old and it's not meant to be used in a way we're using it here, because it just prints things. Right? It prints the output in a nice tabular form, but the columns are just split by white spaces. So it's very unambiguous in a way that we cannot figure out where is the border of a column, which is pretty much a breaker or a blocker for certain combinations. For instance, the arguments or the command especially the arguments can certainly have white spaces, right? So we cannot just split at white spaces, because if not, we have a pretty ugly table in the end. So other tools like Git, for instance, or ls, you can split everything by null bytes, which is nice, which is unique and easy for formatting. Long story short, we had to implement our own PS, and now we're parsing everything in the procfs, which takes a little bit time, but there's no other way on Linux than parsing procfs. But it allowed us to write the library, the PSGO library, with the thought of containers. So it's aware of what a container is. It will join the necessary namespaces to extract the data, so on and so forth. So at the beginning, we have a list of things, of all supported ones. So here we have the arguments of the command, the binding capabilities, the effective capabilities, the inherited capabilities, and the permissive capabilities. Don't ask me the difference. I always have to read the man pages, and every time I feel stupid because I don't understand them at the beginning. I somehow always look at the effective ones, because those are the ones that are actually effective for the process. We have the command, we have some time group, the host group, labels, and so on. So you can use them in different combinations. It will also, if you're running on Ubuntu or on Debian, you can also inspect the AppArmor profile that is currently attached. If I recall correctly, this should be also yes, that's also hidden behind label. This is why we say security attributes and not SE Linux, for instance. So Podman, the name of Podman actually stands for Pod Manager. What is a pod? A pod is a concept that we inherited from Kubernetes. It's a group of containers that share certain resources. Most likely, the PID namespace, the network namespace, and then depending on what we want else to be shared. So Podman supports this concept as basically from day one. So here we can create a new pod, which is called pod test. Now we create a new container and attach it to the pod. I think this is actually wrong. This should just be a Podman create. I guess that's a typo in the echo statement here. So if we do a Podman create -- pod, we can specify or tell Podman to create a new container and put it into this pod. We do the same again. And if we do a Podman PS, we will see that, oh, right, there's no container running because we just created the pod, we created the containers, but we didn't start them. So now if we start it, I don't know what's wrong in the script. If we do a PS now, we actually see that 2 containers are running. I replicated it locally, and it's running. So there must be a bug in the demo script. Just ignore it. Yeah. Now you can trust me for sure. The 2 containers are starting. So the concept of pods is really nice. Many users approach us for how can containers communicate? How can I name containers? Because Docker supports creating new networks and attaching names to it, and it's able to map a container name to basically the IP, to the network of the container, so you can use or talk to, or you can ping pod tag, : and then the port. This is something Podman does not yet support. Why? Because CNI, the container networking interface, doesn't support it yet. It's an open standard, but we're working hard at the moment and prioritize it very highly to get it working. Long story short, our answer is always put them in a pod and then talk to localhost and then a port on localhost. So this is a little bit hacky. It's not really hacky. It's just a different way of letting containers talk to another. I would argue if you need containers to talk to another, then it may be wise to put them in the same pod as well. Kubernetes does the same. And now we can stop it. Well, maybe I was talking too long and the pod doesn't exist anymore, but here you can see it really doesn't exist anymore. We remove it, we list it, there is no pod anymore, and this is the end of the demo. So I'm not Dan, so I'm not sure what else he wanted to talk about, but maybe you have some questions. Yeah.
Yes, when creating a pod, and then running a container inside that pod, is there a way to, when you create a container, is a pod name, you attach a pod name, to have the pod be created automatically, and not have to create the pod, then attach the container?
All right, the question was if I can also create a new pod at container creation, right? So here in the demo, I was first creating a pod and then creating containers, and which were then part of this pod. Yes, you can. You can, so Podman create and Podman run, they basically share the same options, the same flag. So you can also do it for Podman run. So if I do now, Podman run, oh, I don't want to do demos live because I'm not as much as a cowboy as Dan is, but we're in this together, so you can help me. Right, so here I run, it should be like this. So we run a new container, or a run is basically a create and start at the same time. We say we want to attach it or put it into the pod which is called live. If I do a Podman pod list, we see bar and foo, but live doesn't exist. And we run it, we detach from the container immediately and run top. All right. I thought it would work. I was certain it would work. All right. Either I was wrong or we added support for it at a later point. Let me try out something. All right, so this is currently not possible, apparently. I was convinced we support it. Any other questions? Yeah, Tomasz.
So how much work is happening on the Linux kernel side to have better support for containers?
So the question was how much support or how much work is going on in the Linux kernel to better support rootless containers. I honestly am not able to mention all of it because I just have a limited focus and I'm using the kernel. I'm not much working on it lately, but there is a lot of stuff going on. A big problem always seemed to be file systems, right? Overlay, for instance, requires caps admin, so it's not usable by a non-root user, which is why we have overlay implementation in Fuse or in user space. So there are a lot of workarounds going on. Then one big thing or one big topic that is also going on is what is a container, right? There is no such thing as a container in the Linux kernel, which is also why there's the cool t-shirt. I'm not sure if he's still there. The containers are Linux slogan, right? A container is nothing special. In the end, every process is in some namespace under or in some C group, but the ones for containers are just a little bit different. However, it would be nice to know which processes are running within a specific container. So there is the idea of adding or introducing the concept of a container ID. So when you create the init process of the container, so the first process in this namespace, to attach an ID to that, similar to the login UID, which cannot be altered anymore. And there's a lot of work going on from Red Hat engineers, but also from Canonical, from SUSE. So there's a lot of people having interest in it, but it's hard to find consensus. How to do it, where to do it. So I think, Divyansh, I guess is it tomorrow or on Saturday, the Google Summer of Code presentations? On Saturday. So here in the front row is sitting Divyansh. He was working with Dan, Giuseppe Scrivano, and me this year on a Google Summer of Code project. And the idea we had was basically to add another feature to Podman. Podman allows to generate systemd unit files already. It allows to generate a Kubernetes YAML file. And Dan is all about security, right? So we thought, how can we make Podman more secure? How we can help users to secure their containers and lock down the containers a little bit more. So we also want to generate a seccomp profile. So what seccomp does, it's basically a filter mechanism in the kernel where you can configure system calls to be allowed or forbidden. And this goes, it can go down on a very fine granular level, also down to the arguments, but this is basically what every container engine out there does. And the most portable way is to have a whitelist approach. So it allows for, so this list includes all system calls that a container can execute. And there's a default one that was created a few years back by Jessie Frisell from, or at the time she was working at Docker. And this was a really Herculean task. Because you can imagine, this standard whitelist is currently used for basically all containers out there. So finding a set of system calls that every container can execute without breaking is really, 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 really tough. Yet, all other system calls are implicitly forbidden. So it's a way of having yet another onion layer of security around the containers and for certain things. And well, it's but for sure to support all containers out there, or nearly all containers or workloads out there, it's very loose, right? Devansh, do you remember how many system calls are enabled? It's 180 or something like this? All right, so it blocks 44. So it depends really on the kernel version that you're using, but it's obvious that we can erase many of the 200 or 300 system calls depending on the kernel version. We don't need everything, and if you really want to lock things more down, it would be nice to have an automated way of doing it, because it's non-trivial to figure out which system calls might be executed within the container. Yes, you can strace, but I guarantee you will miss something, because there's still runc, and runc will create the process, and there are certain system calls that are required for runc to then create the init process. Long story short, we were working on that with Devansh, and Devansh really did an amazing job there. We have an open pull request at the moment that we're working on to support exactly that. And to come back to the concept of having a container ID in the kernel, this would be amazing to have. Because how Devansh solved it was, so we were looking at a few things, or at a few mechanisms to do it. We could use ptrace, but this is slow and has an impact on the performance, which may have some side effects on the control path and the execution paths within the container, so we might miss things. And then Devansh said, why don't we use eBPF? Everybody's talking about it, so now let's do this. So we were looking at that. And in eBPF, we have access to a lot of data of a process in the kernel. And we were trying to figure out, well, now we have this eBPF filter, and we want to filter, or we want to log the system calls that are executed by a given process. But which one is inside the container? Having an ID, which is in the proc structure of a process in Linux, would be ideal, because it's one comparison. It's super cheap, right? We can be certain that this is a process in the container, right? There can be dozens or hundreds, at least in theory, processes running within the container, and we need to figure out, is this process on the host in another container or something completely different? So we had to work a little bit around this and do an approximation based on the namespaces and the IDs. So if the container if processes inside the container create new namespaces, we might be missing information. But this is as close as we can get. So this is something from our perspective, a very recent story, or it's still ongoing at the moment, where work is going on in the kernel. It's not yet finished, and it's hard to find consensus, because there are many people who have different views, different use cases, different opinions, and finding consensus there is something long. I guess the first article on LWN is already 3 or 4 years old, and we were full of hope, like, okay, maybe perfect timing, and this gets into kernel. I guess it was 5.2, but then Eric Biederman, he said, like, sorry, no. Some folks from Canonical, LXC, LXD, they said no, they want to rethink how they're going to do it, which is great. They're doing a lot of great stuff. A lot of other work is going on with respect to security. So at SUSE, for instance, there's Alexa Sarai, who is working on a lot of on security, in particular for containers, and a lot of attacks also recently came by escaping via the file system. So you escape the container at specific execution times, for instance, via symlinks. Or there was another one. Oh, I had to read it up, how exactly it works. Earlier, after the Chaos Communication Congress, there was a CVE released by replacing. The problem was that runc was dynamically linked, and you still see runc in the container. And if you handcraft a container image with a malicious libc, then with a few nasty tricks, you can basically escape the container and then have access on the host. So there's a lot of work going on in locking things more down. I would say in the kernel there's two big things, which is rootless, how to get this done, and then there's also security. Yes. Hmm?
Whenever we are faced with the question, is system working in this Podman, Docker, Podman request, we are always like, we don't know, let's try it. Usually it doesn't work the first time because we just figure out that something, if you assume is available on Linux, it's just not available in this particular implementation of containers, you know?
Mm-hmm.
And they're always sort of playing catch up. We just don't know
Yeah.
what APIs are available. Like last week it was basically let's just try to run this system in Podman Rootless. Of course it didn't work. We worked around it, but still it's, I mean, it's sort of broken because Podman cannot run it right now on Linux v2.
Right.
System B running in a container sort of requires you, for it to work, it requires delegation on C groups, but delegation on C groups doesn't, I mean, it doesn't work with C groups v1.
You need V2.
Only with V2,
Yep.
but the lib container doesn't work with V2, so, I mean, system includes in the container, some of the APIs are just not available, they don't work.
Right.
Or they pretend to work, but they do nothing, which is even worse, I would say.
Yeah. So the question was, well, it was a lot of information actually. I think last week we were on a call. I didn't see the face, but I remember your voice. But I was silent because Giuseppe, he's doing all the C group work at the moment. So I think if I rephrase, please tell me if I rephrased it correctly, is which kernel APIs are available, which things you can expect to be available in a container. I would say everything and none, because it's really hard to say what's inside a container and what is a container. So from it depends what we're talking about. If it depends on the mount points, this is something we can more or less control. If it depends, or if you're looking at the syscalls, then it depends on the kernel version that we're running and on the seccomp filter that we're using at the moment. And with systemd, I'm not entirely up to date with the recent work on C groups. But as far as I understood that, well, one problem is that C groups we've won, as you mentioned, is it doesn't allow delegation, which is something that C groups v2 supports, but then we have the problem that runc doesn't support it. However, with Fedora 31, we will enable C groups v2 and then things have to change. So how it looks like is runc will be too late for Fedora 31 to support C groups v2, so we will switch over to crun, which is an implementation by also Giuseppe, who wrote an OCI compliant container runtime, but fully written in C. Right? Runc is written in Go, and Go has a lot of limitations in the sense it doesn't allow fork and things like that. Then the runtime has some implications because there are some routines running in the background, so you cannot fully, or you cannot unshare in all circumstances. So there are some weird tricks needed for runc to execute runc and then exit and then do basically a double fork and things like this, which are not that hard to do in C. So I hope that with respect to systemd support in the containers, not everything is supported, as you just mentioned, because some things, there are just some limitations. But with the C groups v2 work, I guess things will improve dramatically. Mm-hmm.
You can write from multiple places and it doesn't enforce sort of a single write. Conceptually, that was the design at the beginning.
So I'm not working on it, so I cannot tell you for sure. Giuseppe is definitely the person to talk to. My guts tell me I would be surprised if we wouldn't use systemd for it. So there's basically two ways of configuring C groups, or two managers we're calling it. One is cgroupfs, and the other one is systemd. And I'm pretty sure we will use systemd also for all the delegation there. All right. Any other questions? I guess you need coffee as much as I do. So I hope to see you in 35 minutes. Then I'll be talking a little bit about Builder. Thanks.